Okay, so for my first multiple choice question, the question is, which of these must be negative for a reaction to be thermodynamically favorable? So going through the answer choices, we can automatically eliminate question, oops, that's the wrong thing right there. We can automatically eliminate answer choice number C, because for it to be for a reaction to be thermodynamically favorable, delta S does not have to be negative. It could be, but it's not. A negative delta S value is not thermodynamically favorable, so that's not a must. So we can cross out C. For delta H, same kind of applies. If we using the Gibbs free energy question or equation, you know that under certain temperatures that delta H value can be positive, and the whole entire reaction still could be thermodynamically favorable. So we can then cross out delta H. So then we're narrowed down to delta A for delta G at standard temperature and pressure, and delta G. So you're always going to be using this at standard temperature and pressure, this little zero at the top. So this one does not have that little zero at the top. That's just change in Gibbs free energy. So we're not going to use that one. So your answer is delta G, and that is A. Our next multiple choice question is, given the following thermochemical data, determine the heat of the reaction. So this is going to be a Hess's law problem. So to solve these, you're going to try to find you're going to try to manipulate these two equations here to make it look exactly like this. And so whatever you do to this, you have to change with the enthalpy, and you're going to be trying to find the heat of the reaction. So to do this, let's first try to find what will balance the first part. So you have two NO gas. So right now, this is on the correct side of the equation, and there's no other places where there's NO gas. So that's perfect. Next, what you're going to try to find is your O2 gas. So if you look at this, there's that O2 on that side. Perfect. Works great. Looks great. Okay. Moving on. So then next, okay. So in this problem, you're given the following thermochemical data, and you're going to determine the heat of reaction. So in this one, you're going to be using Hess's law to find this. So basically, you're going to manipulate these two equations right here, and you're going to try to find how you are going to get this final equation right here. And then you're going to add up all these enthalpies, and you're going to get your heat of the reaction, of this reaction right here. So whatever you do to these equations, you have to do to the enthalpies of the equations. So let's start off with the first part of this and see if this is balanced out. So you're given two NO gas, and this right here, this is the only equation that has that NO gas and is on the correct side of the equation. So that is all set. You don't have to do anything with that. Next part, you got your O2 gas, and if you look up, that O2 gas is on the correct side, and you don't have to do anything with that. It's a perfect number of moles, so that's good. So then you come across your 2NO4 or N2O4. So to do that, the only place that has it is in this equation, but this is on the wrong side. So to fix that, what you're going to do is you're going to flip these two, so it's going to be 2NO2 gas yields N2O4 gas. So cross that out. And so since you flip this, you have to change the sign of this one. So instead of being positive 57.93 kilojoules, it's going to be or I can leave that there. It's going to be a negative 57.93 kilojoules. Okay, you got that N2O4 on that correct side. And also this 2NO2 gas and that 2NO2 gas cancel each other out. So that works out perfectly. So then what you're going to end up getting is you're going to be getting a delta H value of negative 57.93 kilojoules plus that negative 113.14 kilojoules. And what you're going to end up getting is a negative 171.07 kilojoules. Right here, kilojoules. And then you go to your answer choice, and it's going to be answer number C. Answer choice. So the final question here is, which of the following is most likely true? Sorry about bad handwriting, but we'll go through it. So answer choice number A says combustion of organic compounds have negative delta H values or enthalpy values. B says a positive delta G indicates a thermodynamically favored reaction. And C is a positive delta S always means that the reaction is thermodynamically favorable. And D is a thermodynamically favored reaction always goes to completion. So let's go through these answer choices. So we know B is wrong right away because a positive delta G indicates a thermodynamically favored reaction is just not true. It is a negative delta G value that indicates a thermodynamically favored reaction. So we can cross out that one right away. Okay, moving on to answer choice C, a positive delta S always means that the reaction is thermodynamically favorable, and that is not true. Under certain temperature conditions, using Gibbs free energy equation, which is delta G, or I'm assuming that we all know that, we can say that that is not true because under certain temperatures, a reaction can be thermodynamically favored. So that is wrong. A thermodynamically favored reaction always goes to completion. That also is not true because depending on the temperature, the reaction might not go to completion even if the reaction is thermodynamically favored, meaning that the delta H values are thermodynamically favored, or the enthalpies or the entropies are all those are thermodynamically favored, but the temperature might not be correct to make that reaction thermodynamically favored. So that is wrong. And so moving to why A is correct, combustions always mean that there is an exothermic reaction. It's an exothermic reaction, which is going to be releasing heat. So a negative delta H, a negative enthalpy, that's exactly what that means. That's going to mean it's exothermic. So A is your correct answer. Okay. So my topic is thermodynamics, and